Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Acidity of CH bonds depends on the stability of the conjugate base, carbanion. Key factors are aromaticity of the anion, inductive electron withdrawing effects, and hybridization. Moving on to the next step. Analyze compound, kiss smiley, cyclopentadiene. Cyclopentadiene has an sp3CH2 group between the diene. Removal of H from the sp3 carbon gives the cyclopentadienyl anion, which is aromatic, 6 pi electrons in a 5-membered ring, Huckel's rule, 4n plus 2 with n is equal to 1. This aromaticity provides exceptional stabilization to the conjugate base, making cyclopentadiene a relatively strong CH acid, pK-16. Moving on to the next step. Analyze compound Z1 cyanocyclopenta 2,4 1 Yl 1 cyano 1 H cyclopenta 2,4 diene I cyclopentadiene with a CN group at C1. The sp3 carbon at C1 bears both H and CN. Removal of the H gives a cyclopentadienyl anion that is A. Aromatic, same as cyclopentadienyl anion 6 pi electrons. B. Additionally stabilized by the electron withdrawing CN group through inductive effect and resonance, CN can delocalize the negative charge further. This double stabilization, aromaticity plus CN withdrawal, makes compound Z more acidic than compound kiss smiley. pK of Z is lower than that of X. And for the final step, analyze compound Y cycloheptadiene 1, 3 cycloheptadiene or similar. The 7-membered ring with 2 double bonds has an sp3CH2. Removal of H gives the cycloheptadienyl anion. This anion is not aromatic, it would be a 7-membered ring with 6 pi electrons, but the geometry and count don't give Huckel aromaticity for a stabilized anion in the same way. Actually, cycloheptatrienyl cation is aromatic, not the anion. The carbanion from cycloheptadiene is not stabilized by aromaticity and may even be antiaromatic or non-aromatic. Thus compound Y is much less acidic than cyclopentadiene, kiss smiley. pK of Y, pK of X establish the order. Z is most acidic, aromatic anion plus CN stabilization. X is next, aromatic anion alone, cyclopentadienyl. Y is least acidic, non-aromatic or destabilized anion. Decreasing order of acidity, ZXY. Why other options fail? A. XYZ, wrong, ignores CN stabilization on Z and overestimates Y. B. YXZ, wrong, Y should be least acidic. C. ZYX, wrong, Y should be least acidic, not between Z and X. D. ZXY, correct. Therefore, the correct answer is D. Therefore, the correct answer is option D.